Right, we're going to have a go at this Cambridge Maths Paper 3 core from October, November 2021. 2 hours. Let's see how quick we can do this one. First one, alright, they're selling a cup of coffee that costs $3.25 and a glass of cola that's $2.15. Let's write that down. Okay, so we got $3.25 for the coffee and $2.15 for the cola. Gary buys 2 cups of coffee, so it means we're going to times that by 2, and 4 glasses of cola. Okay, must be buying this for a family. Work out how much change he receives from a $20 note. So let's first work out how much it costs. Alright, so that cola will be $3.25 times 2. Oh no, this is the coffee, sorry. That will give us $6.50. And the cola would be $2.15. 4 of those. That will give us $8.60. We add that together. Yeah, we can do that without a calculator. What's that? 15, 10. Alright, don't be scared to double check. Okay, 15, 10 it is. Now, he pays with a $20 note. 20 minus 5, 10. So we can type here a 20 minus our previous answer, which was 5.10, and there we go, $4.19, and that's what it is. Correct answer only. You don't have to put the 0. Okay. Question B. Roy spends $37.80 in a cafe on food and drink in the ratio 7:2. Work out how much he spends on food. Okay, this ratio here for 7:2 means if he pays $7 for the food, he pays $2 for the drink. Okay, that would be a total of $9 he spends. But he's not spending $9, he's spending $37.80, of course. So if we divide that 9 I just got into that, it tells us how many times we need to use this ratio. 37.80 divided by 9. Okay, so that's 4.2. Okay, so it's like having this ratio here, 7:2, and we want an equivalent ratio to that. So for example, we can times it by 2, so we got 14 and 4, but that will equal a total of $18. What we want is we want that to equal $37.80. Okay, so let's get my rubber here. This is all irrelevant information. So what we're going to do is we're going to multiply this ratio by 4.2. Okay, so 7 times 4.2. That will be 29.4, 29.40. And 4.2 times 2, that will be 8.4. Okay, we know this is correct because if we add it together, 29.4 plus 8.4, we get 37.8, which is 37.8. That's what he spends. Okay, so that makes sense. The question is, how much did he spend on food? Food being the first ratio there, which means is the one that goes on the 7. That will be 29.40. Okay, got it right again. Don't have to put the 0, but put it because it's money. It looks nice. Okay. Question C. The price of a train ticket is increased by 12%. Find the new price of the ticket. So the quickest way for me is to use the multiplier, right? If we are increasing something by 12%, we take the whole amount, which is 100%. We add 12% to that. We end up with 112%. You can do this in your head. You don't have to write this down. Now remember, percentage is out of 100. So if we write 112% out of 100, that gives us 1.12. That's our multiplier. So all we need to do is do 48 times 1.12. And we have the answer 53.76. Okay, yeah, that's right. So you see all this big part here. Where's my pen? Okay, this big part here is just what I said, 1.12. So you just can type 48 times 1.12, and I give you 4 marks. Full marks, not 4 marks, full marks. Right, train timetables. We're going from Washby to Dunsley. All trains take the same time to travel from Washby to Dunsley. Complete the table. So first we need to see how long does it take from, okay, remember we are going down because we're going from Washby to Dunsley. So we're going in this direction. Let's get that clear. So if a train departs at 9:18, what time does it, how long does it take to get to Dunsley? Let's jump. Let's do the leapfrog method. First I'm going to jump 2 minutes to 9:20. Then I'm going to jump from 9:20 to 10. Okay, that being 40 minutes, of course, because time ends at 60. So yeah, and then we jump from 10 to 10:03. And that's in another 3 minutes. So we add that together. 2 plus 40 plus 3. That will be a total of 45 minutes it takes the train. Now we need to do the same here. The next train departing at 11:05. We need to add 45 minutes to that. Let's first add the 5 minutes. That's 11:10. And then we add the 40 minutes. So 11:40 plus 40 is 11:50. And that's the time. We're looking at, oh, we need to write the answer up there. Well, cheetah flaps her ears. 11:50 is the answer. Yep, we got that right. Okay. Right, question 1E on this badly lit piece of paper. We're going to do it. So it says one day Washby station sells 28 senior tickets and 192 adult tickets and some child tickets. Complete the pie chart. So let's see. We don't know how many tickets they sold in total. What we do know is that we got senior tickets. Let's write this down. Senior tickets. There's 28 of them. And what we also know is that got 32 degrees on the pie chart. Okay. Now the thing is, if we know what angle each ticket gets of the pie chart, it will help us to work out other stuff. So if we divide this by 28, 28 divided by 28, of course, being 1, and we divide 42 by 28, which you check with your calculator, gives us 1.5 degrees. We know each ticket is got 1.5 degree slice of this pie chart. So now, if we want to know what angle 192 tickets is going to get, we need to multiply that by 192. That means we do 1.5 times 192. Check that on your calculator and you'll see it's 288 degrees. That's how much of the pie chart the adult tickets is. So we need to draw an angle of 288 degrees. Okay, we got our little protractor here. What's important is that you get the middle of the protractor, and the middle there is also important to use a pencil. Okay, and then what we want to do is we want to rotate the protractor so that we have a 0 on a line. So this is one way of doing it. Got 0 there on the line, so then we can use the outside numbers. Or we can do it this way around. That also works. The middle there, and then we put that 0 on the line. There's another way. So now we're going to use the inside numbers because we start from 0. Now remember the angle we want to measure, 288. So we're going to go around here. You'll see we only get up to 180. So let's mark that. Okay. So this is 180. We want 288. So if we subtract 180 from 288, that of course gives us 108. Is that not? Okay, so that means we've now gone around here from 0 all the way to 180. We need to go another in that direction, 108. So let's check. Okay, so I just swapped around. Remember now we were using the inside number, so we need to go another 108. There's 100. So then we go up to 8. That would be 108. We make a little mark, and then we draw the angle to the edge of the circle. So that's that's 288 degrees. Now that should be correct. We write in there, these are the adult tickets. And these will be the child tickets. Excellent. Right, question 2. From this list, write down a multiple of 24. The multiples, of course, think of the multiplication tables. So 24 times tables. We've got 24. 2 times 24 is 48. 48. Yeah, so we've got 2 times 24 is 48. 3 times 24, 72. Yeah, so imagine you're writing the 24 times table. So the answer here would be 72, because 3 times 24 is 72. Square numbers, of course, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 5 times 5, no, I skipped 4. 4 times 4 is 16. 5 times 5 is 25. 6 times 6 is 36. 7 times 7 is 49. That's the one they got up there, 49. That's a square number. Cube number, okay, where these were the counting numbers squared. Oh, that's to be squared. My goodness, what is going on tonight? That was wrong. These are the counting numbers squared. 3 squared, 4 squared, 5 squared. Cube numbers, okay, will be 1 cubed, which is 1 times 1 times 1, which is 1. 2 cubed, which is 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. 3 cubed, 3 times 3 is 9, times 3 is 27. Okay, you need to learn these guys. 4 cubed, 4 times 4 is 16, times 4 is 64. Okay, etc. Let's see which one we have up there. We got 8. Yeah, 8 is cube number because 2 times 2 times 2. Prime numbers, numbers with only 2 factors. 1 and the number itself. First prime number, of course, is 2, not 1, 2. 1 only got 1 factor, 2's got 2 factors. Then 3, then 5. See, 4 has got 3 factors. 1, 2, 3, 4 is not a prime number. Then 7. Then not 9, but 11, 13. These are the prime numbers. Oh, that's an ugly 3. Okay. Right, so which one of these are prime numbers? There we go, 17. Nothing can divide into 17. It was the next prime number, except 1 and 17. Right, write 420 as a product of prime factors. There are 2 ways to do this. We got the fishbone method and we got the tree method. Whichever one you fancy works. Okay. I like the fishbone method. That's what we learn over here in Spain. So what you do is you take 420 and you divide it. Take the first prime number, right? Can you divide 420 by 2? Yes. That would be 210. Can you divide that by 2? Yes. That would be 105. Can you divide it by 3? Yes, you can. Check. 105 divided by 3. 35. You could have also divided by 5, of course. Then you will just get it the other way around. But that's what 35 divided by 5 is, of course, is 7. And then 7 divided by 7 is 1. And that's where you stop. Okay. So this written as a product of prime factors would be 420 equals 2 times 2 times 3 times 5 times 7. That should give you full marks, but if you want to be fancy, you can write 2 squares instead of 2 times 2 times 3 times 5 times 7. Okay, there it is. Okay. Remember to put the times in between because it says product of prime factors. You have to put the times in. If you just write the numbers, you won't get full marks. Okay, but I do believe if you write 2 times 2 and not 2 squares, you should get full marks. That where it says write it in index form. That's what the little 2 is. Index. Okay. Find the lowest common multiple of 30 and 84. Again, there's the word multiple. Don't confuse that with factors. Multiple, multiplication tables. Yeah, think about this. 30, 60, 90, 120, 150. It's like the 3 times table, just with a 0 at the end. 180, 210. Go on forever. Okay, the harder one though is 84. Okay, what is 84 times 2? Let's use our calculator. 84 times 2, save time. Okay, 168. Now, times that by 3. 500. Oh, no. I need to do 84 times 3. 252. Let's try 84 times 4. 336. It's like we're never going to get there. None of that looks like it's even close to the 30 times table. Let's try 84 times 5. 420. You think that is in the 30 times table? Most probably, because look, that's exactly double 210. Okay. Now, none of these numbers here is going to be in the 30 times table. So, this is the first one here that will be. So, I bet if we continue this on to 420, that will be the only one that matches, you see? Because all of these ends in 0, none of these do. I bet you that's the answer. Now, there is another way of doing it. You can find all the prime factors of 30 and 84 and then find the ones that match. But I think this one was a little bit quicker, a little bit easier. You see that here they describe. Okay. Using that, finding the prime factors. Okay. But look, you also get same thing, a list. If you write a list like I did, a list of the multiples of 384, you get 1 mark already. So you don't have to do all that prime factors things. But that's another method. Send me a message and I'll show you that one. Okay, by writing each number correct to one significant figure. This is the thing that people always leave out. One significant. Show that the estimate for this calculation is 40. One significant figure means we need to round each of these to the first figure. Meaning 9.875. We're going to round to what comes after 9? 10, because there's an 8 there. There's an 8 there, so we do round the 9 up to 10. Here again, we do round it to that 1. What's next to that 1? An 8. So we round the 1 up to a 2. Okay, but 2 is nowhere close to 18.305. That 2 is in the tens column, so we need to put a 0 to show that that is actually 18 rounded to 20. And we're not rounding 18 to 2, we're rounding it to 20. Okay, under the line there, one significant figure, we need to round it at 3. Next to the 3 is a 4, so the 3 stays at 3. Don't put any zeros because it's 3, it's not 30 or 0 point, right? Then we got plus, again, the one significant figure. The first one there is a 2, but next to the 2 is a 7, so we round the 2 up to a 3. We can't round 27 to 3, that doesn't make sense. We need to, again, that 2 is in the tens column, so we need to put the 0 to show that we rounded 27 to 30. Okay, so what does that mean? 10 plus 20 is 30, divided by 3, plus 30. 30 divided by 3 is 10, plus 30, that gives us 40, right? I've shown as much as I possibly can. I can't possibly not get 2 marks here. Let's see. 1 mark, yeah, for correct rounding. And then, yes, showing some working out there. So like adding the 10 and the 20. Just don't assume you can jump from there to there. Showing that you know how to get there. So shows as much working out as possible to ensure you get full marks. Alright. Right, Simone is running a lap in 79 seconds. That's quite fast, isn't it? Well, it's more than a minute. It's good. It's not a bad time. Work out how long it will take her to run 6 kilometers at the same rate. Give your answer in minutes and seconds. Okay, so they want the answer in minutes and seconds. Let's first see how many times will she have to run around that track. Okay, the track is in meters. So let's change the 6 kilometers to meters, alright? And to do that, kilo, meaning 1,000, we need to times it by 1,000. That will be 6,000 meters, okay? So how many times does she need to go around the track? We do 6,000 divided by 400. 15 times she can run around the track. Okay. Now that's now kind of amazing. If she can run at that pace for 15 laps, each lap is 79 seconds. So we do 15 times 79. 1,185 seconds. Good. But who counts seconds like that? We use minutes. Okay, how many minutes and how many seconds in a minute? Of course, it's 60. So we divide it by 60. Let's try that out. Just divide it by 60. Okay, so that will give us 19.75 minutes. Okay, there's the thing down here, right? 19 minutes, that makes sense, but 75 seconds, no, that doesn't make sense. Okay, no, don't let this confuse you. All right, there's two things we can do. We can say, fine, we got the 19 minutes. My pen back. Got the 19 minutes. We're going to times that by 60 to see exactly how many minutes that is. So we just take the 19 minutes times 60. That's 1,140 minutes. So if we do 1185 minus 1140, let's do that. 1185 minus our previous answer, 45 seconds. Now that makes more sense. Okay, that is because this, let's use a different color here to explain this. This 0.75, that does not represent time like we understand it. That is out of 100 because it's a decimal value, and decimal values we count up to 10 or 100 or 1,000, whereas time stops at 60 seconds. So that doesn't quite match up, right? So it's 19 minutes and 0.75 of a minute. Okay, which is 3/4 of a minute. All right, or another way to do it, we take that 0.75, okay, without the 19, and we need to change that to a different counting method, which is time, which is out of 60. So if we do that, 0.75 times 60, see, bam, we get the same answer, 45 seconds. So that's another way. Okay, you don't have to do both ways to find how many seconds it is. Alright, so question 3, 90 minutes, 45 seconds. Okay, and there's a bunch of ways of doing this. You don't have to use each one of them. Alright. Let's look at B. The probability that she does not win a race is 0.94. She's good. The probability she wins is really high that she does not win. Oh no. Probability she wins. Still a good chance though. Final is that she wins the race. Okay, remember, all probabilities always adds up to 1 or 100%. So we need to do 1 minus 0.94. So 94% chance she didn't win. So there's a 0.06 or 6% chance that she wins, which is high. I've never won that many races. 6 out of 100. Okay, C. Right, these are the number of laps she runs. Look at that second day. She ran 42 laps. Amazing. Okay. That was a Tuesday. She ran 42 laps. So Monday 15, 42. Wednesday 28. Saturday lazy 15. Sunday she went for it again. Write down the mode. Remember, mode, the most, the number that occurs the most, right? And there's only two numbers that occurs twice. That's 15. So that's the number that occurs the most, 15. Okay, the median is the middle value. So you want to go 16, yeah? But that's wrong. It's wrong, don't, right? We have to arrange them first from the smallest to the biggest. So we take the 15 and that 15, cross them off, you don't miss any out. What's next? 16. Then we got 24. Then we got 28, then we got 32, then we got 42. Which one is in the middle band? That's not difficult to find. You see, 3 on the left, 3 on the right, 24 it is. See, it's 2 marks. You need to show something, not just the answer, right? The range, you take the biggest. I like to check colors again. 42 is the biggest, 15 is the smallest. 42 minus 15. What would that be? 37? No, 27. Okay. Let's check if we're right. 15, 24. You see, you get a mark for arranging them from smallest to biggest. And then 27. 1 mark. Okay. Right. Now, Wilfred has 5 laps in 59 seconds. Oh, Wilfred. It's not human. Wilfred must be a cheetah or something. Okay. Oh, it's one of those questions. Doesn't make sense. So, 5 laps. That's how fast you run. After running, you see these mean changes. Okay, look at that. How do you work out the mean, right? Maybe this is the mean one. You have to do a lot of working out, right? You need to add up all the laps. 59 plus 74 plus 69 plus 63 plus 65. So that was 5 laps. Then he ran the 6th lap. But they don't tell us. We had to find out what is the 6th lap. Find the time for the 6th lap. So let's say that 6th lap is X. Yeah, X. So then we have to add the 6th lap. And the mean is you add up all the laps. So there's 6 laps you ran in total. Yeah. And then we divide it by how many there is. So we divide that by 6. And then we get the answer. 67 seconds on average. Alright, now we need to solve this whole massive thing. Right, so let's first add up all the 5 laps we did record. So let's start. Yeah, that's them all. So that's 330. Still need to add that 6th lap. Divided by 6 equals 67. Right. Let's move that 6 to the other side. We're going to multiply it. So what is that? 67 times 6. That's it. So we got 330. It's an ugly 3. Make it look better. 330 plus x equals 402. Move that to the other side. So we subtract it. And that will give us the answer. So minus 336 72 seconds. Doesn't make sense. Yeah, because I mean, there was a 74 and the rest is all below it, so it's a reasonable answer. And it is correct, of course, that's what the mark scheme says. Right, angles. Alright, ABC is a triangle. Why do they tell us that? So we can think, triangles, 180 degrees. Good. And it tells us they're parallel. These two lines are parallel. We can see that because we've got the arrows. But they tell it to us, we need to use that. So parallel lines, think F and Z angles. Remember, F or alternate and corresponding. Find the value of X, the value of Y, and the value of Z. Alright, let's start with X. X is right next to 58. Angles on a straight line is 180, so 180 minus 58. Okay, of course that will be what, 122. Okay, let's write that in. So this is 122. Right, what now? We're stuck. What do we do? What do we do? What do we do? What do we do? Oh, we need to find Y. Okay. Have we used the parallel lines yet? No. Let's use them. Let's mark angle Y. No, I want it red. Let's mark angle Y. That is angle Y. And then, now she got out. There we go. There you got that Z. It's called alternate angles. That means that angle Y and 73, and alternate sides of the transversal, that means they're equal. So we got a 73 there. Right, what we left with, oh yeah, they said this is a triangle. We got two angles in the triangle, so we just need to add those two angles together, the 58 and the 73, and then subtract it from 180. Let's not waste our time. 180 minus 58 and 73. Oh, 73. There we go, 46. Let's see what they say over here. 122, 73, 49. Why is it 49? Oh, because I can't read. Because I make an ugly 3. And then I type it as a 6. Who would have done that? Where? Huh? Silly marks. We lose in the exam. Because we're in a rush. 49. Okay, don't make silly mistakes like that. Cost you. Double check. Go slow. Okay. Right. Points PQR lie on a circle center O. Find the value of U. This is a circle theorem that you need to remember. If we have the diameter of a circle and then subtended from there, we have an angle on the circumference. That angle is exactly what it looks like. 90 degrees. Remember that. That's called the angle in a semicircle theorem. Alright, so that, again, triangle, 180 minus, well, now we got the 90 degree angle, and we got the 32. Let's see if I can get it right this time. So 180 minus bracket 90 and 32, bam, 58. 58, thank goodness. I'm still qualified to do this job. Right. So, it's down there. There's a sector of a circle. Radius 6.42 centimeters. And the angle is 72. Calculate the perimeter of the sector. Remember, perimeter means the outside of the shapes. And in the shape, it's got an arc there, a bendy part. And also got a line there and a line there. Okay, so don't forget about those lines. Let's just start with the bendy part. Okay, the bendy part is a part, of course, of a whole circle. How would you do a whole circle? You'll use the area for the circumference of a circle. Circumference of a circle is 2 pi r. Okay, now if we had the whole circle, this would be the radius, and that would be the middle of the circle. So we need to do 2 times pi times 6.42. Okay, but now that's not the whole thing. There's only a part of it, a small part, a fraction of it. Okay, what fraction of it? That's 72. That 72 degrees is 72 degrees out of 360. So we had the whole thing with 360, but we only have 72. That's the fraction. So this is like fractions. So that's what we do. We work out the circumference of the circle, and then we multiply it by the fraction of the circle we have, and that will give us the length of the arc, 8.0676, down rounded. Yet. Okay, so this is 8.0676. Okay, but like I said, this is also the perimeter, that's also the perimeter, so we need to take that 8.0676, etc., and add the radius, not once but twice, because this and that, yeah, and that will give us the final answer. So I still have that on my calculator. So plus 6.42 plus 6.42, 20.907. Right, etc. That's beautiful. You can write it on the line, but I think at the beginning of the paper it said, oh my goodness, where is it? Give non-exact numerical answers correct to 3 significant figures, or one is 3 significant figures. So let's, where is it? So 3 significant figures. Come back. There we go. We need to round it. 1, 2, 3 figures, 20.9. Look at the mark scheme. 20.9, spot on. Okay, but if you haven't rounded it, you still give you full marks. Alright, so don't bang your head over that. Okay, question 5, and here we need to collect like terms. So we got the 5a plus the 7a, that plus is with the 7a. So 5a plus 7a is 12a. And then here we got a negative 3b plus 2b. So minus 3 plus 2, of course, is minus 1. So this will be minus 1b. Okay. You don't have to put that 1. You can just write 12a minus b. Okay, 12a minus b. Right. Question 5. B. This is substitution. We write the 8. Then we put the 5 where the x is. Using brackets is always better. Minus 3, we put the minus 2 where the bracket, where the y is, in brackets. Here the bracket is important because this means multiply. Okay, let's grab the calculator. We just put it in there just the way it is. There we go, 46. That's what we got. 46 it is. Solving, that's where we need to find the value of x. You see, we're getting x alone on the side of the equal. So I'm going to leave the 6x where it is, and I'm going to subtract the 2x on this side. Okay. Keep the equal in the middle so everything is nice and clear. The 8 stays where it is on the right hand side of the equal, and we move the minus 3 to the other side. It becomes plus 3. So 6x minus 2x is 4x. 8 plus 3 is 11. And now the 4 times x, when we move the 4, it becomes 11 divided by 4. You can write it just like that. Okay, let's see what the marks keeper says. 11 over 4. Does it say how to write the answer? No. Okay, so I believe if you write 11 over 4, it's fine. But if you want to be on the safe side, you can always change it to a decimal, or if you press shift, a mixed fraction. Okay, so 2 over 3/4 or 2.75. All of those answers are correct. Now, question D, make t the subject. It's kind of the same as what we just did, but now we just get the t alone, and we're not solving it. So again, when we got p equals 6, let's make that 6 look better. 6t minus 11. We need to move the minus 11 and 6 to the other side. Always start away as far as possible from the t. Okay, so we're going to move the minus 11 first. That becomes plus 11. And then this is 6 times t, so when we move the 6 to the other side, we need to divide everything by 6. So that's the answer. P plus 11, everything divided by 6. As it is there. Alright. Question E, simultaneous equations. Alright. They've already nicely lined up the x's and the y's for us. Okay, so here it shows that the elimination method would work best. Elimination method is where we add or we subtract the two equations to try and eliminate the x or the y. Then we could solve the other one. Problem here though is if we add or subtract, the x's, we will not eliminate it because they're not the same. Same with the y's, they're not the same. So the first step would be to try and get the number in front of the x or the number in front of the y correct. So there's two ways of doing this, and I'll do both. Okay, one after the other. So look at first. First thing I will try is get the x's the same. So common multiple of 3 and 2 is 6. So if we multiply the first equation by 2, everything by 2, that will make the 3x 6x. That makes it minus 4 minus 8y, and that will make the 30 into 60. We then multiply the second equation, everything by 3, because 2x times 3 is 6x, and this is what we wanted. We wanted the number in front of the x to be the same. Okay, but we need to multiply everything by 3. So 3 times 5 is plus 15y, and 3 times minus 3 is minus 9. Okay, now we need to decide if we're going to add or subtract. Remember, we want to get rid of the x's in this case. So if we're going to add them, 6x plus 6x is 12x. That's not going to work. We haven't got rid of anything. So in this case, if they have the sign, they're both positive, we're going to subtract them because 6x minus 6x is nothing. It's 0. We have eliminated the x's, which is awesome. That's what we wanted to do. Next is the minus 8y. Then we got the minus here. Okay, remember now, I should put brackets here because we're subtracting everything. Plus 15y, which is the same as minus y minus 15y. Remember, a plus and a minus is a minus. So that will give us minus 23y. And then next we got 60 minus a negative 9. So in this case, two negatives makes it positive. So this is the same as 60 plus 9, which is 69. Okay. Now the last step, that negative 23 is times y. Okay. So, you know, like negative 23y is the same as negative 23 times y. It's not the same as y minus 23. Don't get that confused. So that means when we move the negative 23 to the other side, we're going to divide it and it's going to stay negative. The negative doesn't become positive because we're not adding it to the y, we're multiplying it. So our final answer here, 69 divided by negative 23 will be negative 3. Okay, if you're any doubt, check it on your calculator. 69 divided by negative 23. Right. So we got the y. Next step, we can write it down here. It's -3. We still need to find the x. So the next step will be to put that negative y back into one of the equations. We can put them in any one. The first one, the second one, or one of the ones we changed. Doesn't matter. You pick any one. Let's do the first one. Let's check the first equation, which is 3x minus 4y equals 30. And we change the y for a -3. So that becomes 3x minus 4 minus 3 equals 30. Okay. So let's see. -4 times -3 is, of course, a positive, because 2 negatives makes it positive. 12. We can then subtract the 12 from the 30. That will give us 18. Divide the 3, and we got the answer 6. Okay, you can check if it's correct. You don't have to do this. This doesn't count marks, but if you got time, right? Take that second equation, which is 2x plus 5y equals -3. Substitute the 6 and the -3 in there. So we got 2 times 6, because x is 6. And we got y is -3. So 2 times 6 is 12. 5 times -3 is -15. 12 minus 15 is -3. And we know we've got it right. That is the correct answer. Okay, like I said, this is not necessary. It doesn't count marks. What counts marks here is that you get the x's or the y's the same. Then you eliminate one of them, and then you get the two answers. Okay, so basically if you go back here, alright, I've got the two x's the same, 6x. We eliminated one of them, so this step, then we get this answer, and then final mark for getting that answer. Okay, as my dog starts barking there. Right, the question is though, I'm quickly going to show you the other way of doing this question. And if you don't want to watch this, just skip it forward, of course. But that would be to get the coefficients, the numbers in front of the y's the same. So to do that, we would multiply the first equation by 5 first, which will give us 15x minus 20y equals 150. And then we'll multiply the second equation by 4, which will give us 8x plus 20y equals minus 12. Okay, that's good now because we got the coefficient in front of the y the same. Alright, the thing here is now, if we subtract them like we did the other time, that's not going to work because minus 20y minus plus 20y is minus 20y minus 20y will give us minus 40y, and that's what we want. We want to eliminate the x or the y. So for this one, we're going to have to add them because minus 20 plus 20y is nothing, and that's what we want. So 15x plus 8x gives us 23x. 150 plus minus 12 will give us 138. Okay, the next step will be to divide the 23, and that will give us 6, of course, because that's what we already worked out last time. But we always double check. 130 divided by 6, bam, 23. There we go. From here on, it's the same. We just substitute that 6 into one of the equations above. Let's do the first one again. So instead of having 3x minus 4y equals 30, we put the 6 where the x is. That will give us 18 minus 4y. Okay, we can subtract the 18 on the other side, so that will be 13 minus 18. So we got minus 4y equals 12. Divide the 12 by the negative 4. Right? It's not add the 4 because minus 4 times y becomes divide, and that will give us minus 3. So we have the same answers as before, and we know we got it right. Question 6, write them from the smallest to the biggest. I think for me the easiest is just change everything to decimals. Okay, so you grab your calculator if you can find it. Okay, there we go, and you do 11 divided by 19, or 11 over 19, change it to a decimal, and that will be 0.5789. Okay, you know what, write them over here, because if you line them up, okay, I'm doing 4 decimal places because the first one is 4 decimal places. It will make it a lot easier to compare them. And then we do the 17 divided by 29. That gives us 0.5862. Okay. And the last one, of course, 58% is the same as 50 divided by 100. 0.58. Okay, what you can do, you can add 2 zeros because it doesn't change the number. Okay, so this is on that side of the decimal to help you compare it. Okay, so make sure you do this right. The smallest first. Which is the smallest? Here you can see the smallest will be this one, of course, because it's 5.7, while the other one is 5.8. Okay, so that will be 0.5789, which is the second one. So that's 11 over 19. Okay, done that one. Next smallest, now we can look at the thousandth column, which we have the smallest. So we've done this one. Smallest there. There's a 0, there's a 0. This one's got another 0, and this one's got a 6. So this will be the next smallest, which is the last one. Okay. Now we can compare. This one is in smaller, of course. Still looking at thousands columns. This one's got a 0 there. So the first one is the third smallest or second biggest. And then the last one was 17 over 29. Right, there we go. 11 over 19, 58%. 0.5506 and 17 over 29. Okay. B rounded to 3 decimal places. There we count the decimal places. 1, 2, 3. So it means we cut it off after the 4. But after the 4 is a 9. Means we need to round it up. That's 0.005. Significant figures, though, that works different. Significant figures, we don't count the zeros in the front or the back. We do count a 0 when it's between numbers. So this means these 3 zeros, they don't count as significant numbers. The first significant figure is the 4. The second one is the 9. And the third significant figure is 7. Or it's 2 significant figures. So after the 9, we cut it off. Next to the 9 is a 7. That means we need to round up the 9. How do you round up a 9? Well, it's not just a 9, it's a 49. What comes after 49? 50. So this will be 0.0050. Okay. Now what about that 0 at the end? It doesn't actually mean anything. Is it important to write it? Now, yes, if you round it to 2 significant figures, you put that 0 to show people, no, talking about this 0, to show people that you've rounded it to significant figures. But will you get full marks in the exam if you don't put the 0? That is the question. And it seems they are very strict on this. Yes, you have to put that 0 because it says correct answer only. That's what CAO means. So they seem to want that 0 there. It's not always been. This is the first time I see this actually. So put the 0, even though 0.005 is the same number. They want you to put that 0, just to show you've rounded it to 2 significant figures. Question C. We've got a flagpole and it's measured. And when you see correct 2, this is the key words here, correct 2. Let's highlight that. Correct 2. Okay, that means that this number here has been rounded to 2 decimal places. As you can see, it has only 2 decimal places. So the question here is, what could the numbers have been before you rounded it? So when we write the answer here, we need to write 3 decimal places. Okay, meaning it's probably going to be 37.123 3 numbers, and 37 and 1, 2, 3 numbers. What is that? Okay, the first thing we need to work out here is called the lower bound. And how do we find that? We need to take this number, 37.84. We need to find the lower bound. What is the smallest number we can write that will round up to 37.084? One way to help you find what you need to subtract here is write a number to 2 decimal places. 0.01, that is 2 decimal places. Divided by 2, always take that, divided by 2. Okay, I wish I could show you more questions. We could practice this. What do you get? 0.01 divided by 2, 0.005. See, 3 decimal places. That's what you need to subtract. That will give you 37.835. Okay. You can imagine like 840. What is the smallest number? You go right up to 840. It's 835. See? So that will be our lower bound. That's what we're going to write over here. 0.835. Okay. For the upper bound, we're going to do exactly the same. 37.84. Only we're adding this time. And that will be 37.845. Okay. Now, I hear you. You're coming with a question. 845 will write to 850. Will it not? Well, yes, but that's why we have this sign here, which means the number is less than but not equal. Okay, so that's why we put 845, meaning it's not equal to 845. It's the number just under. Yes, 37.849 recurring, which you could have written as an answer in different circumstances, but because we got the less than there, you need to write 37.845. Okay, as the mark scheme shows. Okay, note that in the mark scheme I've written them the wrong way around. Okay, the way I wrote it, that is correct. Oh no, that's right. It's the right way in the mark scheme as well. It's the same. The population of Algeria is 201 million. That's a lot. Correct to 3 significant figures. Write this population in standard form. Okay, remember, standard form is a number which can't be bigger than 10 and smaller than 1. So meaning a number point something something times 10 to the power of something. Okay, meaning if we have the number 201 million, the decimal point of course is the end. We need to move that decimal point to over there to make it 2.01. Okay, times 10. How many spaces have we moved it? 1, 2, 3, 4, 5, 6, 7, 8. 10 to the power of 8. Okay. Your calculator can do this for you if you know how to change the settings. If you press Shift Setup and you change your calculator to Psi, which means scientific notation. Okay, we have 3 significant figures, so we press 3. Okay, let's clear the answer. Then it will give it for us in scientific notation. So let's put in this 201 million into the calculator. Press equal. Bam, there's the answer. Smart. Great, because you want to change it back, you press shift, setup. We want the calculator on normal, so press 8. You press 1 or 2. I'm going to go into what that means. 2 is usually better. Now it's back to normal. Okay. If you want to spend the time and check it out. Okay. Now, question E. We still have standard form, so I think it will be smart to change our calculator back. Shift setup to scientific notation. And I see they all got 3 significant figures, so we press 3. Okay, we got it back in psi. You see the little psi up there. Alright. Table shows the population of some countries given in standard form, correct to 3 significant figures. Use this information table to find the country with the smallest population. Okay, be careful now. It looks like it could be China, but it's not, because China has got a 9 there. That means it's actually bigger, it's more, okay, than other numbers which got less. So in fact, China is the biggest number because of that 9. It's by a factor 10 times bigger than Brazil, and by a factor of 4 times bigger than the Maldives, which would be the smallest, because it's 10 to the power of 5. Okay, so the country with the smallest amount of smallest population being Maldives. Okay, the country with the population that is nearest to 5 million. Okay, what is a million? Million, of course, is a 1 with 6 zeros, which in standard form would be 1 times 10 to the power of 6. So I'd recommend we look at the numbers which has a 10 to the power of 6, and there's 2 of them. Okay, so remember what I said, you can put that into your calculator. Let's see, 5.31. Press this button here, put 6. We put that in. We want it as normal. Press shift, setup, normal, 2. There we go. 5,310,000. That's what Eritrea's got. 5,310,000. But New Zealand's also quite close to 5 million, is it not? That would be 4,790,000. Which one's closer? Let's have a look. Okay, let's subtract 5 million. 6 zeros, yeah. So that's 310,000 away, of course, logical. What about this one? Let's take 5 million. And subtract from that 4,790,000. Bam, 210,000. That's closer. That's definitely closer. 210,000, 310. So the answer being here, New Zealand. Okay, last one. The difference between the population of Brazil, what's that? 2.12 times 10 to the power of 8, and the population of France, which is 6.55. Difference, meaning subtract. Got your calculator. Okay, let's switch it back to scientific notation. 3 significant figures. Clear that. Put 1.12 to the power of 8 minus 6.55. Let's take the power of 7. And there we go. 1.47. Let's take the power of 8. That doesn't feel right, does it? Could that be right? Yeah, it's right. But it's given my answer to 3 significant figures. And here they give it to 4 significant figures. Why did it do that? It gave my answer to 3 significant figures because when I changed the setup and they asked for a number, I put 3. If I would put 4, Now I give us 4 significant figures. Question is, would they mark that correct? The mark scheme is not very clear on this. And I would say it's better to have more significant figures. So my recommendation is have more figures there. Okay, of course there's other ways of doing it. So you can change them to normal numbers and then have the answer as a normal number like that, which is more accurate. So, you know what? I'm gonna be very strict here and say, this is wrong. You should go for 1, 4, 6, 5 times 10 to the power of 8. Partly because they say at the beginning of the paper as well, give non-exact numerical answers correct to 3 significant figures and 1 decimal place 4 degrees. Okay, non-exact. Non-exact means you have like a bunch of decimal numbers like pi, 3.14 and they carry on. That's not exact, but I mean, now this question, it is actually exact. Okay, so be more accurate. I lost the mark there. Or maybe you won't, but just be sure. Be sure I'm saying you're going to lose a mark. Right, the value of k correct to 2 significant figures where the population of China equals k times the population of Eritrea. So, meaning, let's just write down, this is confusing. Let's write down the population of China, which was 1.42 times 10 to the power of 9. Like that. 1.42 times 10 to the power of 9. Because that's what they total population of China. Then they put an equal, then they put a k, then they put a time, and then they wrote the population of Eritrea. So let's write down the population of Eritrea, which is 5.31 times 10 to the power of 6. Okay, so they ask, what is k? This is solving an equation. So we're going to take all of this, move it to the other side, and of course, we do the opposite of times, we divide. So 1.42 times 10 to the power of 9 divided by 5.31 times 10 to the power of 6. And that will be k. So we just need to do that on the calculator. Okay. I'm going to put my calculator back into normal mode. Okay. There we go. Right, let's do that. Use the fraction button. You don't have to. You can use the division button. Maybe use brackets. I prefer to do it this way. And that's what we get. 267. 0.419, etc. That is what is k. Okay. Now they mention here 2 significant figures, which means 1, 2. We need to cut it off there. That's when we round it to 2, 7, and put the 0 because it's not 26, it's 270. 270, correct answer only. Okay, you get 1 mark for doing that division sum there. Okay, or if you show the non-rounded answer. Right, 7a, we got 2 shapes. So let's do them separately. Let's do, first of all, call this 1. Okay. It's a circle or a part of a circle. We're talking here about area. So you will write down the formula for the area of a circle is A equals pi r squared. But this is a quarter of a circle, not the whole circle. The whole circle, of course, would look like something like that. Only a quarter, so we're going to have to divide our answer by 4 to get the area. You don't have to add the radiuses on, 15 and 15, because you only do that when you do perimeter. Don't get confused. So this will be pi And we got 15 there. Is that the radius? Yes, because if it was a whole circle, it will go from the middle. So that would be 15 squared divided by 4. Okay, so let's get our calculator out. And there we go. Don't round this answer, because it's not the final answer yet. So write at least 4, maybe 5, maybe 6 significant figures. Okay, a bunch of them. Right. Then we got the trapezium. The trapezium, which is the shape at the bottom. Now this is probably the most forgotten formula any year 11 student has. This formula: a half a plus b, not times, a plus b times h. A and b being the two parallel sides of the trapezium, and h being the perpendicular height that forms a 90-degree angle. Okay, tattoo this on your forehead so you'll never forget it, because everybody forgets it. Alright, so A and B, the two parallel sides, in this case again it's 15 and 22, times the height being 12. Let's put that in the calculator, save ourselves some time. Okay, you can put a half as 0.5 to save some time if you want. 15 plus 22 times 12. Oh, nice. 222. Of course, to get the final answer, we're going to add these two together. Quick tip to do it quickly. You see, no, it's not going to work. I can just push plus and then put all those digits in. $398.714. Now this is not an exact answer because it's got loads of decimals and continues, so put that to 3 significant figures. So we cut it off there, so 39 next to the 8 is a 7, so we round it up, which is 399. Okay, looking at the answer here though, if you write the unrounded answer as well, you will get full marks. They are not too strict on that. Question B, right, it's a rectangle, and they're talking about the area of a rectangle. The area of a rectangle is always length times width. Gives us the area, of course. Here the length is h, the width is 15.8, and they give us the area, which is 387.1. So if we want to find h, all we need to do is divide the 15.8 on the other side. So do that. There we go. 24.5. That is the height. The h. Bang on. 24.5. Question C, we want us to work out the volume of the prism, not the surface area. Don't get these things confused. Okay, best thing here to do is work out the area of the front face, which this works for any prism. Okay, any prism. So the area of a triangle is half base times perpendicular height, which is half the base being 18, the height being 15. Okay. So again, 0.5, put quicker. Times, you can put times, you can put brackets, whichever you prefer. 135. Okay, this is okay, centimeter square, of course. Okay, that's the area, but we want volume. How do you measure volume? In centimeters cubed. So we short centimeter there. That's when you take the area of the front face and you multiply it by the length. 32 centimeters. Centimeter squared times centimeter squared gives you the centimeters cubed. So we have that, which is 135 times 32, and we got 4,320. Correct. Question 8, similar triangles, which means the factor is the same. Okay. Means if we divide this by that, we should get the same as when we divide this by that. Okay, it's like a factor of 2 or 3 or a half. Okay, so one way of doing this is by starting what they want to know. They want to know what is EF. Let's write it down. Now this is like a ratio, the factor. If we do EF, divide it by the corresponding side on the smaller shape, which is 14.8, we will get the same answer if we take the length on the bigger triangle we have divided by the corresponding side on the smaller one. Okay, so here I put the big triangle at the top, the small one at the bottom. It's the same. So now we just need to rearrange. Take this 14.8, which means divided here, and we multiply it there. So it's 74.9 over 21.4 times 14.8. You can also write that 14.8 at the top. Same thing, 74.9 times 14.8. Divide. Okay, doesn't matter which order you do it in. It works the same. Okay, over 21.4 times 14.8. Okay, 51.8. If you understand what I just meant, look what happens. Let's go back. You can put that at the top as well, 14.8. And you get the same answer. Okay, which is correct, 51.8. Right, angle BCA. So, angle BCA. Let's do this on a different color. Okay. BCA. BCA is this angle there. So, okay, what is this angle? What are we going to do? Find an angle. Think carefully here. What's going on? How can I find an angle? Okay, we don't have this angle, but these angles are the same anyway. With similar shapes, the angles is always the same. What can we do? What can we do? What can we do? Right. Right angles, there are two things that you need to remember. There is Pythagoras, which works great if you got two sides, you want to find a third side. Okay, Pythagoras only works with sides. So in this case, we're not going to use Pythagoras. And then there's the other one, Socatua. Now Socatua works with sides and angles. So let's label this triangle, right? Got my angle, BAC, BCA, ACB, BCA. Okay. What is what here? Well, the longer side opposite the right angle, that of course is the hypotenuse. Opposite the angle is the opposite angle, which is a side, which is not relevant here because we don't have it and we don't want to know it. And then right next to the angle, we got the adjacent. Now here we're working with the hypotenuse and the adjacent. The A and the H, which means we use the second ratio, which is cos. So let's write that down. Cos what? Cos the angle. The angle we don't know. This is angle BCA equals, where are we? You see the A is first and K, so we put that at the top, 14.8. Divided by the hypotenuse, which was 21.4. Okay, now we need to get the angle. To get the angle, we're just rearranging stuff. So for this we need to move the cos to the other side. The opposite of plus is minus. The opposite of times is divide. What's the opposite of cos? Well, you get your calculator there. Opposite of cos, cos minus 1, right above cos. Put it in your calculator. Shift, cos, fraction. And bang. 46.243. And round that, being an angle, we round it to 1 decimal place, so that will be 46.2. 46.2. If you write the unrounded answer, also correct. You get a mark for writing the ratio. Smart, smart, smart. Question 8b. The diagram shows two congruent. Congruent means exactly the same. It means this rectangle is exactly the same as this rectangle. Tiles placed together. The width of each tile is 32.5, so we can see that. And GH, so if you draw a line from G to H, is 84.5 centimeters. Find the length of each tile. So the length means this, and there's two of them next to each other, but we just need to find one of them. Okay, what you need to recognize here is that this forms a right angle triangle. Okay, so that's a right angle. Of course, it's a rectangle. They told us it's a rectangle. We know it's a right angle. Okay. When you got a right angle triangle, you know it's either going to be something to do with SOHCAHTOA or Pythagoras. Now remember, SOHCAHTOA we use when there are angles involved. If they give you an angle or they want to know what's an angle, use SOHCAHTOA. In this case, we're not using any of the angles. We're not finding any of the angles, so we're going to use Pythagoras, which we use in right angle triangles when we are working with just the sides. Okay, so first thing we're going to do is we're going to work out what is this side here. Let's call it X. Alright, next thing we need to do is recognize the hypotenuse, the longest side, which is this one, of course, the side opposite the right angle. That means if we're going to write down Pythagoras, the hypotenuse 84.5 squared equals 32.5 squared plus this side we want out, x squared. Okay, we can rearrange that. Okay, we move that to this side. Okay, it's going to be subtraction, so I'm going to write it like this. So x squared will be 84.5 squared minus 32.5 squared. You see? To give you the hypotenuse, you want to find one of the other sides, it's always subtract. If you want to find the hypotenuse, you're always going to add. Okay, and you see I did one thing wrong here. Okay, put the square root there. What I meant was, now if we want to work out x and get rid of that square, we're going to have to square root all of this. Now this equation is correct. Square root gone, square gone, square root on the other side. So we can pluck out the calculator and put that in. 84.5 squared minus 32.5 squared. 78 it is. So x is 78. Be careful now, that's not the final answer. Okay, that means simply that the whole length of the two tiles is 78. If we want to find the length of one tile, okay, one over here, we have to divide that by 2. So 78 divided by 2 will of course equal 39. So final answer, 39 centimeters. Let's have a look. Yeah, there it is. Okay, as you can see, you get marks for writing down the Pythagoras theorem, subtracting, for square rooting, and halving it. Right, we're on question 8c. And again, we'll do this on this badly lit piece of paper. And it says, let's start here. Town B is 72 kilometers from town A on a bearing of 58 degrees. So let's first do that bearing. Remember, bearings we always measure from north. So we always put our protractor with 0 facing north. And we always go clockwise. So we're always going to put the protractor like this. Put the middle on A exactly. There we go. And now we need to go 58. So 0, 10, we're using outside numbers because we're going from 0. 58 would be over there. Be as accurate as possible. Now the temptation people usually has is just to take the ruler and draw a line and stop at that dot there. But remember, that dot's the distance from my protractor. That's not the distance they want us to do. They want 72 kilometers on this scale where 1 centimeter is 12 kilometers. So let's write it down here. Let's write it. 72 kilometers. So how do I get from 12 to 72? I need to multiply it by 6. 12 times 6 is 72. So we times this by 6. That means 6 centimeters is 72 kilometers. So then I take my ruler. Make sure you got the 0 at A. And then you use the dot we made at 58 degrees to get the right angle. But we need to draw a line stopping at 6. Exactly. Okay, so that dot just only tells me which direction it is, but that's not where we stop. We stop at 6. Okay, so that would be town B. So clearly indicate there, this is town B. Okay, then it says town C, 60 kilometers due east of town B. Okay, what does due east mean? Remember your compass rose. North, south. If you go there towards the east, it's that way. Japan, China, you know, the east. Okay, and then there's the west, Europe, Americas. If you look at the traditional map, that is. So due east will be flat there going that way. Let's just make sure, okay? Try to get this right. Yeah, remember, we're going to need to be parallel with north. Still need north. And then due east would be exactly at a bearing of 90 degrees. Okay. So then town C would be in this direction. But well, we don't know how long to draw that line yet. Again, we're going here for 60 kilometers. So we use the scale of 1 centimeter is 12 kilometers. We now need to multiply 12 by 5. 12 times 5 is 60. So we do 1 times 5, which is 5 centimeters. So that's the next thing. This line has to be 5 centimeters long. Due east, flat, horizontal. So this time you see my dot is there, so I'm going to stop before my dot. There we go. Okay. And that would be town C. And now we've done it. Okay, so when they mark this, they will check if the angle is correct and if the length of the line is correct. Okay, there, due east and the length of the line. Last thing it says, measure the bearing of town C from town A. So it means we're at town A, we need to measure the bearing to town C. So to help us do that, we're going to connect A and C. And now when we measure a bearing, okay, can put the middle of the protractor on the sketch at A because we're measuring from town A. Make sure we have it exactly 0 at the top. We use the outside numbers and we see 60, 70, and then we count the small line 71, 72, 73 is what I get. And remember, bearings is always 3 figures, so we put the 0 in front. Now, hang on for a second or two. I'm going to check the mark scheme. And here, the mark scheme actually doesn't give an exact answer. They say follow through. So depending on what your sketch looks like, they will determine if they're happy with that answer. So if you made a mistake there and you measure the bearing correct according to your mistake, then you'll get this answer, this mark as a follow through mark. Okay, so they're not specific about that angle. But if you got 73 like me, it means you're probably right because I'm a genius. Right, question 9 is all about transformations. And I think the first thing you need to do is you need to remind yourself of the 4 different transformations there are. Okay, there is of course reflection. When you look in the mirror or when something flips over, mirror image. There's a rotation. When something spins around, and that's helpful to have some tracing paper for that, yeah. When something spins, that would be rotation. Ooh, something coming up. Okay. What's the other one? Enlargement. That's when something changes size. And what else do we have? Oh yeah, this one. Transportation. No, some people write transportation. It's translation. Okay, don't get it wrong. Don't get confused. Sorry, I said that word before because then people only remember that one and they forget translation. Translation. Tell yourself translation. Like going from one language to another. That's translation. Okay. So let's look at the questions. Describe fully the single transformation that maps T onto triangle A. T onto A. Now there's only one where it changes size, and that's enlargement. Okay. Even though with enlargement, sometimes it gets smaller, we call it enlargement. So is this one getting smaller from T to A? No, it's definitely getting bigger. Okay, from T to A. If it's from A to T, it will still be enlargement, but it will be smaller. Let's see. This triangle is 2 squares high. This one is 4. This triangle's base is 3. That one is 6. So it's very clear that it's twice as big. So we call this the scale factor is 3. See, there's 3 marks. One for enlargement, one for scale factor. We need to write one more thing, and that will be the center. The center of enlargement. Okay. To find that, we need to grab a ruler and we connect the corners. You see it like this. Connect those top corners. Let's connect those bottom corners over there. And already something's happening. Well, we connect the last two, the 2 right angles. There we go. See, they all come together. All comes together. And this point along the corridor, down the stairs, -1, -1. So the center usually is a coordinate. Okay. 1 mark, 1 mark, 1 mark. Don't leave anything out. Get full marks. Next one, describe fully the single transformation that maps triangle T onto triangle B. Okay, so now we know it's not going to be an enlargement, it's not changing size. Okay, is it a mirror image? Let's trace it. Oh, you can see that? Mirror image just kind of flips over. If there was a reflection, it would have been like that. Okay, it's not a reflection. With a translation, it doesn't change orientation, it just moves along the page. Okay, so if it was a translation, it would have looked something like that. It's not a translation, is it? Only be a rotation. So let's write that down. Okay, rotation. So we have 1 mark already. Remember, we need 3 marks here as well. So, smart thing to do is put your tracing paper on top of it. Take your pencil. Let's try the point 0, 0. Definitely a rotation. See that? Okay, how much does it turn? How much does it turn? Is that a quarter turn? Half a turn? Okay, one way to ensure you get this right is take the center now. We know this. Let's write it down. Okay, because we know the center is the point 0, 0. Or the origin. Because that's where I put my pencil when I put the tracing paper. Okay, if we connect a corner with the center and we connect another corner, this one's already connected. Okay, what's that angle? 90 degrees. See, you can do that with any of the corners. This corner to that corner. 90 degrees. Okay, so that tells us it's 90 degrees rotation, but that's not the full story, of course. You need to say what direction, and we were going like this. Look at the watch in the exam hall, on the wall, clockwise. And yes, you can say 270 anti-clockwise, of course. Right. Excellent. 3 marks. Rotation, center, direction. Last one. On the grid, draw the image of triangle T after the translation. Okay. Of vector 5 minus 3. Now remember vectors. The top number tells us left or right. If it's positive, we go to the right. Just like the numbers on the x-axis there. And the bottom number tells us up or down. If it's negative, we go down, just like the numbers on the y-axis. So this one means we need to go 5 to the right and 3 down. 5 to the right because it's positive, 3 down because it's negative. So, again, tracing paper, triangle T, 5 to the right, 1, 2, 3, 4, 5, and 3 down. 1, 2, 3. Okay, keep the tracing paper. Mark the corners. And draw your shape. Bam. Full marks, because you're a genius. Beautiful. We're looking at question 10. I think it's the last question on the paper. Right. Complete the table. So, first position here, -2. We want to put that into the equation over here. And the best thing to do here is use brackets. So, you're going to do -2 squared minus 5. I mean, you don't have to use brackets, but you can never go wrong with brackets. You can't go wrong without brackets. Okay, so let's do that. -2 bracket square. See? Here the brackets is very important. -5, -2, -2. Bam. 12 is the first one. Okay. Next one, then we put a 1 where that -2 was. Okay, you can retype everything. You can do it in your head, or you can go like this. Put the 1 now instead of a -2. Okay, so everything is still the same. X squared minus 5x minus 2 is now 1 squared minus 5 times 1 minus 2. And that gives us -6. Last one, we now put a 4. Change that 1 for a 4. And we got -6 again. And you notice we got a nice pattern going here. Okay, -8, -8, -6, -6, -2, -2, 4, 4, 12. That's because this is a quadratic equation. Right, let's plot the points. Use a pencil. And let's see. Remember this. Along the corridor, up the stairs. So -2, 12 over there. Next one, -1, 4. Along the corridor, -1, up the stairs, 4. And do the rest. Right, and then by freehand, make a nice smooth curve. Make sure you go through every point. Just curve at the bottom, don't flatten it off. And back up. But probably there at one point, okay? Don't do feathering. Do just like this. Don't draw more than one line. Just one smooth line, okay? One smooth line. Right. Question C. Okay, on the grid, draw the line y equals 2. Okay, y equals 2. The line y equals 2, right? That's the y-axis. There's the 2. So what you need to do here, draw a straight line horizontal through y equals 2, which is really hard on my screen here. There we go. Okay, in pencil, of course. Okay, let's use the graph to solve the equation. So you see the first part of my equation is the equation of the green line I have here, which we had over there. Okay, and the second part of my equation now, they've taken that y, because y equals x squared minus 5x minus 2, and they've taken away, and now we got a 2, which means y has been changed for 2, which represents that line. So all we need to do now is say where y equals 2 and the graph we have crosses each other. And that would be, I'm going to use a light green. You see they cross here, so we go down from there. Okay, each dot counts for, what is this, 5.2, 5.4, 5.6, 5.8, 6 is 5.8. Okay, 5.8. And over there, the other side, this will be 0, minus 0.2, minus 0.4, minus 0.6, minus 0.8, minus 1, yes, minus 0.8. Let's see what the mark scheme says. Okay, between minus 0, where's my highlighter? Come here. Between minus 0.9 and minus 0.5. So my minus 0.8 fits there nicely. And the other one between 5.5 and 5.9, my 5.8 fits in there as well. So that means I'll get full marks. Okay. And then everything is blank. It means we're finished. Sweet, sweet, sweet.